Alright, so we're going to look at optimization and so look at kinematics and optimization because they work quite well. If I've got a function xt equals negative 4.9 t squared plus 40t minus, no, I'll go plus 2. So that's an object. What does xt represent? What does that function represent for looking at kinematics?
Position.
Yep, position. Very good. So that deals with position. Now we might get asked, find the maximum height the object reaches. Something like that. So anytime we hear the word maximum, what do we need to be thinking? Max or min? If I hear the word max or min, what am I assuming I need to do?
High or low.
Yep, I want a high or low. How do I find those points?
The turning point.
I look for a turning point. How do I find a turning point for a function? Derive it and let it equal 0. So x dash t equals negative 9.8t plus 40. Cool? What does this function represent? So that's our velocity, so I'm going to let that equal 0. And then I solve for t. What does that equal? Let's go 4.1. I don't know if that is exactly what it equals, but you get the idea. Oh, Sasha, if you want to show that, that'd be great. Am I done?
No.
What do I need to do?
Find the maximum height.
I have to find the maximum height. What else do I have to? I have to find out the actual the position value, but I'm not quite there yet. What is it? Geez, I'm good.
You put that value in.
Do I know it's a max? How do I prove? Double derive it. Am I done?
No. Because it's.
I have to shove my value in. Yeah, so it's just negative 9.8. What does that tell me? Because it's negative, I know it's a max. So because my double derivative so I've proved it's a maximum. Now what do I have to do? Sub it back into.
So you can look at coordinates.
Yep, I need the coordinates essentially. I have to shove it into that equation. You guys can put that in. I should have changed my T, I'll do it now. But can someone put that in their calculator before I get too far into this? What does that give me? What is it?
244.37.
Okay, so that's the maximum height that object reaches, or something similar to that. So that's kinematics and using our double derivatives to find a max or a min. That's not quite optimization, but it links very closely. Cool. Remember with our kinematics, we have the ladder. Oh, that's not how we do the ladder. If we're going Down the ladder, what's the process? Derive. If we're going up the ladder, anti-derive. If you ever forget, what should you look at? The units. What's the units for meters? Oh, sorry, what's the unit for position? What's the unit for position? Very good, you're all switched on. That's the first one you've all got correct. The units for position are meters. The units for time, seconds, or whatever, let's just go seconds. So in this situation, if you derive meters with respect to time, you get meters per second, which is the unit for velocity. Meters per second squared is when we derive the velocity by time. Cool? So look at your units and that will tell you what you're doing as far as that if you forget. Are we good with kinematics? We happy with that?
Yeah.
Good. Anytime you see XT, that is talking about position.
So